Hello, today I'm looking at M3 International A-Level January 2017. This is question 6. So we have one end of a light elastic string of natural length 5A and modulus of elasticity 20 mg is attached to a fixed point A. A particle P of mass 2m is attached to the free end of the string and P hangs freely in equilibrium at the point B. Find the distance A, so that's from the fixed point, to B where the particle is hanging freely. So I will begin by drawing a diagram of what is happening. So we have A, we have the natural length, which will be 5L, and then I'll have the extension while it's in equilibrium, which I'll call x0. Then the particle is at B. Separately from this, I'll draw a diagram showing the forces that are acting on the particle. So I have the weight acting down. Now the mass was 2m, so the weight is 2mg. And the force up will be the tension in the string, which will be, I'm using the formula lambda times the extension over the natural length. So I have lambda, which is 20 mg, the modulus of elasticity, multiplied by the extension, which is what I called x0, divided by the natural length, which was 5L. And as it is hanging in equilibrium, the acceleration will be 0. So that means, using Newton's second law, the forces up will equal the forces down. So here I get 2 mg equals, here I can see 20 divided by 5 will give me 4 mg x0 over L. So dividing both sides by mg and then dividing both sides by 2, I get this, and then to make x0 the subject, I'll multiply by L and then divide by 2. So I get x0 is L over 2. Now they wanted the distance AB, so AB is 5L plus x0, so plus this value. So that will give me, if I do it in halves, 5L is 10 halves, so 10 halves plus 1 half is 11 halves L. Okay, so that is for 3 marks, that's part A. Then it says the particle is now pulled vertically downwards from B to the point C and released from rest. In the subsequent motion, the string does not become slack. Show that P moves with simple harmonic motion with center B. So now I'll draw a new diagram. So A is here, I have 5L, I have my x0, which was L over 2, and then the string will be extended beyond that, so I'll call that x. This time the weight is still at 2mg. The force up, though, will be very similar to what I had before. Before I had this, which ended up being 4mg over L. 4mg over L multiplied by the extension. Now the extension this time is L over 2 plus x. And as x is measured from this, the equilibrium position downwards, then x double dot, the acceleration, will also be measured down. So doing Newton's second law vertically, then I will have forces down minus forces up equals the mass times the acceleration. So forces down minus forces up equals the mass, which is 2m, multiplied by the acceleration. Watch out on these questions every time the mass is something that's other than m. Okay, I can see I've got 2m everywhere, so I can divide everything by 2m. And to end up with x double dot as the subject, that's all I need to do. So here I get g. Here I've got 2g over L multiplied by L over 2. Well, the L's will cancel, the 2's will cancel, and I'll be left with negative g. And then I will get minus 2g over L multiplied by x. So this part will cancel out, and I'll be left with just this. And so therefore I've proved simple harmonic motion omega will be the square root of whatever is written here next to the x, and the center will be b because this is where I measured x from. They said center B, yes, center B. Okay, so that is part B for 5 marks. Then in part C, it says find the period of the motion. So to find the period of the motion, I use the formula T is 2 pi over omega. So the period is 2 pi divided by omega. So here I just need to divide by this. 2 pi divided by this is 2 pi multiplied by the reciprocal of this. So 2g will end up on the bottom and the L will end up on the top. And I can leave my answer like that. Or 2 is really root 2 multiplied by root 2. So on the top I have a root L, on the bottom I have a root 2 and a root G. So one of those would cancel, giving me pi times root 2L over G. But this answer would be acceptable as well. Okay, so that is part C, which is worth 2 marks. Then it tells me the greatest speed of P during the motion is this, and I'm asked to find the amplitude of the motion. Well, I know that V max is A omega, and this can be kind of deduced from the equation V squared is omega squared A squared minus X squared. You can see the biggest value of this will happen when X is 0, so that will disappear, and so you end up with this formula. And so they have told me that this is the value of the Vmax, so I can pop this here. So I've got root GL over 5 equals A multiplied by omega, and looking back, my value of omega was this. So I have root 2g over root L. Okay. And now I just need to rearrange this to give me A. Now I've got a root G on both sides, so those will cancel out. And then to get A, I'll multiply both sides by root L. So here I'll end up with root L times root L will make L. The 5 will stay on the bottom. And then this root 2, I need to divide by it, and it will end up down here. So you could rationalize this and multiplying bottom and top by root 2, so you would end up root 2 multiplied by L over, and on the bottom you would end up with 5 times root 2, so 5 times 2, which is 10. Okay, so that gives you the value of A, that's worth 3 marks. And finally it says point D is the midpoint of BC, and the point E is the highest point reached by P. Find the time taken from P to move directly from D to E. So here, first of all, let's get clear about where each of these positions are. So point A was here. Point B was where the center of the simple harmonic motion was. So point B was here. Then point C was the point where it was released from at the very bottom. So point C is the amplitude kind of away. So this from here to here is the amplitude from B to C. Okay, so point D is the midpoint of BC. So D is in the middle of here. And point E is the highest point reached by P. So because okay, so if we look at the highest point reached by P, the highest point reached by P is going to be when it reaches the top of its amplitude. Now, the amplitude was this, and if I just stick this in my calculator a moment just to get an idea of how many L this actually is, if we do root 2 divided by 10, this is 0.14 L. And so that gives me an idea of how big this is. So if we're talking about half of that, then we are looking at X will be half of A. So at point D, X is, so the extension will be half of A, which will be this divided by 2. So I'll end up with root 2 L over 20. Instead, when I'm looking at point E as the highest point reached by P, that is when the amplitude is reached kind of on the other side of B. So that will be at this highest point, which will be A away from B. So at point E, the extension will be A, which is root 2 L over 10. So if I want the time taken to move from one to the other, then I could look at the time for it to go from basically no extension from the equilibrium position to the middle of BC, and then look at from no extension to the other side, but it's going to be equal on either side. So if I just work out these two times, then I can just pop them, add them together. So I'm going to use the equation X is A sine omega t, and I know that so at D, then I end up with X is root 2 L over 20 is A root 2 L over 10 times sine multiplied by omega, which was this thing, root 2g over L times by t. So these cancel, these cancel, these cancel, and so I just get a half inverse sine of a half will give me this thing here. So to get the value of t, I would need to multiply by the reciprocal of this, so L over 2g square rooted. Then if I look at do the same thing with E, then this time I will end up with basically A equals A, so I'll get 1. And so I'll get exactly the same thing, but with a 1 here, because here and here I have the same values as each other. Okay, so I need to make sure my calculator is in radians, and I'll do this. Hang on. Yeah, okay. So I'm going to have this plus this, basically. So total time will be root L over 2g, this plus this. So if I do inverse sine of a half, I get pi over 6. And if I do inverse sine instead of 1, then I get pi over 2. So pi over 2 plus pi over 6 gives me 2 pi over 3. And so I end up with root L over 2g multiplied by 2 pi over 3. Okay, So that last part of the question was worth 4 marks, and the total marks for the question were 3 plus 5 plus 2, that's 10, plus 3 plus 4, another 7, so you've got 17 marks altogether for that question. So I hope you found that solution helpful. Good luck with your revision. Do click like if you liked it, and catch you next time.